Welcome back, everyone. You know, the tech landscape hasn't just shifted, it's practically teleported over the last few months. Today, we're zeroing in on the absolute cutting edge, what tech circles globally are calling Ahadeth Adawat al-Dhika al-Istana'i 2026, or the absolute latest AI tools of 2026. Our mission for this explainer? Cut right through the marketing hype and unpack exactly how these tools have violently yanked us out of the experimental phase straight into an era of autonomous execution. Let's get into it.
Here's our roadmap for today. We're going to kick things off with the AI revolution of 2026, then break down exactly how these generative models actually work under the hood. From there, we'll look at the giants of large language models, check out the latest video and content tools, dive into the serious power of open source, and finally wrap up with a bulletproof framework for choosing your tool.
All right, part one, the AI revolution of 2026.
So, the sheer speed of model releases at the start of this year has been literally unprecedented. It really forces us to ask, has AI actually moved from just experimentation to true execution? Think about it. For the last couple of years, we were basically just chatting, right? We'd prompt an AI, it would spit out a rough draft, and we'd do all the heavy lifting to finish it. But the Q1 data for 2026 shows a massive, undeniable paradigm shift. We aren't just brainstorming anymore. We are handing over the reins. We're relying on AI to do the work, double-check its own errors, and actually deliver the final product.
Just think back over the breakneck timeline we just experienced in Q1. In January, Google dropped Gemini 3.1 Pro with some seriously deep workspace integrations. Literally the next month, February, Anthropic answers back with Claude 4.6, which completely shattered what we thought was possible with agentic coding. And then, bam, March hits, and OpenAI unleashes the GPT 5.3 family. It's wild. Month by month, the foundational limits of artificial intelligence weren't just pushed, they were completely rewritten.
Moving on to part two, how generative models work. Now, to really grasp what these tools can do, we have to understand the science powering them. In the grand taxonomy of generative AI, the models are fundamentally split into two main branches, based on maximum likelihood. You've got implicit density models on one side and explicit or approximate density models on the other. I know. It sounds super academic, but basically, it's just describing the underlying math of how a model decides what a real image or a real piece of text is supposed to look like based entirely on its training data.
Let's make this a bit easier to digest and break down the architecture into three main heavy hitters. First up, we've got GANs, or Generative Adversarial Networks. Imagine two neural networks locked in a battle. One generates fakes, the other acts as a detective trying to catch them, and they push each other until the result is incredibly realistic. Second, we have VAEs, Variational Autoencoders. These guys learn the underlying probability distribution of data in what's called a latent space, which makes them absolutely fantastic for generating smooth, continuous outputs. And third, we have diffusion models, which literally build something out of pure noise.
Let's actually zoom in on diffusion models for a second, because they are the absolute computational powerhouses behind almost all the cutting-edge visual tools we use today. The way deep learning architectures process this is fascinating. It happens in two phases. First, the model takes a perfectly clean piece of input data and gradually destroys it by adding Gaussian noise. It essentially turns a crisp photograph into complete unrecognizable static. Then, the real magic happens. It learns to systematically reverse that exact process to reconstruct a pristine, high-quality synthesis from the static. It is a wildly powerful approach to generation.
Okay, part three, giants of large language models.
So, when it comes down to choosing between the big three developers right now, it's all about understanding their very distinct specializations. OpenAI's GPT 5.3 Codex, for instance, has hit unprecedented ratings specifically for cybersecurity and vulnerability identification. It's a powerhouse for security. Then you have Anthropic's Claude 4.6 Opus, which is just dominating when it comes to autonomous agent tactic coding. It can genuinely navigate computer environments like a human developer would. And Google? Well, their Gemini 3.1 Pro is leaning super heavily into integration, silently and seamlessly powering your entire workspace ecosystem.
But I want to pause on one very specific, very crazy number, 14.5. And to be clear, that is not a benchmark score, that is time. 14.5 represents the consecutive hours that Anthropic's Claude 4.6 Opus can now operate totally autonomously on complex workflows. Just imagine this. You hand an AI a massive coding or data analysis project right before you go to sleep. It works tirelessly, checking its own bugs, navigating spreadsheets, and managing files for 14.5 hours straight without needing a single prompt or nudge from you. That right there is the very definition of execution.
Let's pivot to part 4, video and content tools. For all the creators and marketers out there, you already know AI isn't just about writing code. It is completely eliminating the massive, soul-crushing bottleneck of manual video editing and content repurposing. In 2026, we're seeing two totally distinct approaches dominating the space. On one hand, you have Descript, which completely revolutionized editing existing footage. You literally just edit an AI-generated text transcript, like a Word doc, and it automatically cuts the video to match. On the flip side, you have Runway ML. Here, you're using cutting-edge generative models to conjure up entirely new, hyper-realistic footage from absolute scratch, just by typing a text prompt.
Let's rapid fire through a few more of these text-to-video champions. Got a super long, kind of dry text blog? Run it through Pictory, and it auto-converts it into a punchy, short-form video featuring all the key highlights. Lumen 5 takes a slightly different route, transforming your text into highly engaging animated templates that are tailor-made for social media. And then there's HeyGen. HeyGen just completely removes the need for a camera altogether by generating these ultra-realistic talking head AI avatars that can seamlessly speak in over 100 different languages. It's absolutely unreal.
All right, part 5, the open source power.
Now, I know what you might be thinking. This all sounds amazing, but it's probably incredibly expensive. Well, open source is completely flipping the script. In 2026, developers and enterprises absolutely do not have to rely on closed, expensive corporate ecosystems to get state-of-the-art results. Let me drop a critical metric on you: 2.3x. There's this massive misconception that free open-source AI is clunky or slow. But recent performance tests show that open-source cloud platforms, like SiliconFlow, are achieving inference speeds 2.3 times faster than traditional proprietary cloud platforms. Oh, and they're doing it with 32% lower latency.
There are several free platforms making this a reality right now. SiliconFlow is giving developers incredibly fast integrated AI deployment without any of the usual infrastructure headaches. Hugging Face is still sitting on the throne as the undisputed hub for AI researchers to find pre-trained models. And OpenChat, it's giving chatbot builders conversational AI that is genuinely on par with proprietary GPT models, all while operating on absolutely zero licensing costs. It's a total game changer.
Which brings us to our final section, part 6, choosing your tool.
With all these incredible options on the table, how on earth do you actually choose? We've covered a ton of ground today, and navigating this landscape can feel pretty overwhelming, so you really need a structured, foolproof way to evaluate these tools for your own workflows. First rule, please, do not just trust a tool's marketing hype. You have to run a pilot to test its accuracy on your specific real-world data. Next, look at the depth of the API integration. Surface-level triggers just aren't going to cut it for true automation. Then, you've got to do some serious cost modeling. Project the cost at 10 times your current volume, because tools that seem super cheap early on can get painfully expensive when you scale up. And finally, check the quality of their documentation and community support. Because trust me, when your automated workflow breaks at 2 a.m., a good community forum is the only thing that's going to save you.
So we've broken down how generative AI actually works under the hood, we've explored the massive proprietary titans, the open source heroes, and we've got a solid framework for how to evaluate them. The experimentation phase we've been stuck in, it is officially over. The tools for true autonomous execution are sitting right there in front of you. So the only real question left to ask yourself is this: the tools are here. What will you build in 2026? Thanks so much for hanging out with me for this explainer, and keep building.